Hello and welcome to our Rust Recipes course. Before we begin, just a little bit about me. My name is Matthew Studley. I'm a software developer, Rust enthusiast, storyteller, and board game designer. Let's get onto the course overview. So in section 1, we're going to be looking at errors and how we can handle errors effectively using the result and option types. In section 2, we're going to be looking at iterators and how we can write them and how we can use them in a way that makes our code fit the functional style. In section 3, we're going to be looking at concurrency and lifetimes. In section 4, we're going to be looking at the builder pattern and how we can make complex objects, and then even we're going to touch on macros. In section 5, we're going to be looking at futures and Rust's capabilities for asynchronous code with async and await. In section 6, we're going to be looking at Diesel, which is a database object relational model. It's a way of connecting to databases from Rust. In 7, we're going to be building web servers in Rocket. And in section 8, we're going to be connecting our code to code written in other languages. A couple of technical terms that are worth covering here. Macros are basically code that writes code. If you've come from a C background, then it kind of changes the text of your code before it gets compiled into binary. In Rust, the macros actually happen at a slightly different point. They happen after the code is converted into its tree. So when you write your macros, they actually work on the abstract syntax tree, which is kind of like what the compiler builds up to look at when it's inspecting the code before producing the output. Because of that, your macros can be very clean and you know that they're going to do what they say they're supposed to. An iterator is something that allows repeating the same thing again and again, normally involved in a for loop, but it doesn't always have to be. I/O is just for input-output, and asynchronous means code where it doesn't matter which operation completes first. So maybe you've got 3 or 4 things happening at the same time, and you don't really care which one happens first, but they do need to communicate between these different processes at certain times. And futures are a structure which helps us to write this asynchronous code. I'll go into more detail on that now. So this is Rust's primary mechanism for asynchronous programming. It's currently managed by the Tokyo crate, and that's kind of where it started. Rust primarily develops through libraries on crates.io, which is kind of where most Rust code is hosted. And when a library becomes really popular, they start considering if it's worth adding to the standard library or if any parts of that are. But most growing development happens in crates, and so it's worth checking out that system. And the Tokyo crate is the main one for creating asynchronous code. There are other libraries around for doing it too. You can continue working on other things while you're waiting for input-output operations to happen, and it can work safely across multiple threads. This is very worth understanding if you're getting into Rust. Futures are a very key part and very exciting field of growth in the Rust language. The primary goals of this course: by the end of this course, you should be confident using Rust's lifetime system. The lifetime system in Rust is a new thing. Not many other languages have this at all, and Rust certainly was the one to start it where the others are getting it. But being confident using this will mean you'll be able to write code securely and confident that you are not going to be introducing all kinds of errors into your code because of this system. You will come to a solid understanding of how Rust's generics work as well and be able to write asynchronous programs in Rust. We'll also get started using Rust's macro system, and by the end of this course as well, you should be able to connect your new Rust code to any legacy libraries or programs you have already written. There are some prerequisites for this course. Basic knowledge of Rust syntax will be helpful. Previous programming experience will be helpful. If you are proficient in any language, this should be fine for you, but it is not a beginner programming course. If you are new to programming, consider my previous Rust in 7 Days course, which should be available through this system. Okay, let's get started. I'll see you in the next video.